Dev Studio. My locker. Again, you put a new lock on it.
Upgraded. 6 digits this time.
6 digits. My chicken rice is going to be ice cold by the time I solve this.
3 clues, same as before, but the maths is bigger.
Bigger how?
Clue 1. The first 3 digits form a number divisible by 6.
Okay, and?
Clue 2. The last 3 digits are the LCM of 4 and 6. Clue 3. The middle 2 digits are the GCF of 12 and 18.
I know what divisible means. Sort of. LCM and GCF sound like secret agent codes.
They are, and I'm going to teach you all 3. Clock is ticking.
Subscribe to our channel. My lunch is trapped behind maths I have not learned yet.
Divisibility. A number is divisible by another if it splits evenly. No remainder.
Like how 12 splits into 3 groups of 4.
Good instinct. Now, here is the shortcut. Rules that let you check in your head. Divisible by 2. If the last digit is even. 0, 2, 4, 6, or 8.
So, 348. Last digit is 8. Divisible by 2.
Divisible by 5. Last digit is 0 or 5.
Easy. What about 3?
Add up all the digits. If that sum is divisible by 3, the whole number is 2. Try 432.
4 plus 3 plus 2 is 9. 9 divides by 3. So yes, 432 is divisible by 3.
Same trick for 9. If the digits add up to a multiple of 9, the number is divisible by 9.
And 6?
Divisible by 6 needs both tests. Even number and digit sum divisible by 3.
So, for the lock, I need a 3-digit number divisible by 6. Let me try 132. Last digit 2, that is even. 1 plus 3 plus 2 is 6. 6 divides by 3. Both tests pass.
But is it the right number? We will come back to that. First, LCM and GCF for the rest of the code.
Those sound complicated.
They are simpler than you think. But you need a new tool first. Prime factorization. Breaking a number into its prime building blocks.
Like how 12 is 2 times 2 times 3. All prime.
Exactly. Every number has a unique prime breakdown. 12 is 2 squared times 3. 18 is 2 times 3 squared.
How do I find the prime?
Factor tree. Start with the number. Split into any 2 factors. Keep splitting until every leaf is prime.
Let me try 36. 36 splits into 6 times 6. Each 6 splits into 2 times 3. So 36 is 2 squared times 3 squared.
Perfect. Now here is where it gets powerful. GCF stands for greatest common factor, the biggest number that divides into 2 numbers evenly.
The clue says the middle 2 digits are the GCF of 12 and 18. Let me try it the hard way first.
Go ahead.
Factors of 12. 1, 2, 3, 4, 6, 12. Factors of 18. 1, 2, 3, 6, 9, 18. Common ones are 1, 2, 3, 6. Biggest is 6.
That works. But watch the fast way. Write the prime factorization. 12 is 2 squared times 3. 18 is 2 times 3 squared. For GCF, take the lowest power of each shared prime.
Shared primes are 2 and 3. Lowest power of 2 is 1. Lowest power of 3 is 1. 2 times 3 is 6. Same answer? Much faster.
Now, LCM. Lowest common multiple. The smallest number that both numbers go into.
So the LCM of 4 and 6, their times tables eventually hit the same number?
Multiples of 4, 4, 8, 12. Multiples of 6, 6, 12. First one they share is 12.
So LCM of 4 and 6 is 12. But is there a faster way like with GCF?
Same setup, opposite rule. For LCM, take the highest power of every prime that appears. 4 is 2 squared. 6 is 2 times 3. Highest power of 2 is 2 squared, 3 to the 1. 4 times 3 is 12.
GCF takes the minimum. LCM takes the maximum. They are mirror images.
Bonus connection. GCF times LCM always equals the product of the two numbers. 6 times 12 equals 4 times 18, both 72.
Let me pause here for 8 seconds. What is the GCF of 24 and 36 using prime factorization? 24 is 2 cubed times 3. 36 is 2 squared times 3 squared. Lowest powers, 2 squared is 4. 3 to the 1 is 3. 4 times 3 is 12.
Now, one more tool. BODMAS. The order you do operations in.
Brackets, orders, division, multiplication, addition, subtraction. I know the letter.
Most students know the letters but mess up the details. Division and multiplication have equal priority. Left to right. Same for addition and subtraction. Equal priority, left to right.
So 8 divided by 2 times 4. I do left to right. 8 divided by 2 is 4. 4 times 4 is 16.
Correct. Students who multiply first get 8 divided by 8, which is 1. Wrong answer. Left to right when the priority is equal.
And brackets override everything?
Always. 2 plus 3 times 4. Without brackets, multiplication first. 3 times 4 is 12. Plus 2 is 14. But put 2 plus 3 in brackets. 5 times 4 is 20. Brackets change the answer completely.
Where do LCM and GCF show up outside exams?
Bus 171 comes every 12 minutes. Bus 96 comes every 8 minutes. They both just arrived at the same stop. When do they meet again?
I need the first time that both 12 and 8 land on. That sounds like LCM. 12 is 2 squared times 3. 8 is 2 cubed. Highest powers, 2 cubed times 3 is 24. They meet again in 24 minutes.
Now imagine you are cutting paper for art class. One strip is 18 centimeters. Another is 24 centimeters. You want to cut them into equal pieces with no leftover.
Biggest piece that fits both. That is GCF. 18 is 2 times 3 squared. 24 is 2 cubed times 3. Lowest powers. 2 to the 1, 3 to the 1. 2 times 3 is 6. Cut 6 centimeter pieces.
3 pieces from the 18 centimeter strip. 4 pieces from the 24 centimeter strip. 0 waste.
So GCF is about fitting things perfectly. LCM is about finding when things line up again.
Factories use LCM to sync machine schedules. Architects use GCF to tile floors with no cuts. Real engineering tools.
And BODMAS? Where does that matter outside school?
Every spreadsheet formula, every line of code. Get the order wrong and the calculation breaks.
Subscribe to our channel. Next, Cipher shows me the PSLE traps hiding in these topics. Hit me with the exam trap.
Trap 1. What is the LCM of 8 and 12? A student writes 96. They just multiplied 8 times 12.
But LCM is the lowest common multiple, not any common multiple. 8 is 2 cubed, 12 is 2 squared times 3. Highest powers. 2 cubed times 3 is 24, not 96.
Rule. LCM is always less than or equal to the product. If you get the product, you probably skipped the prime factorization step.
What is trap 2?
Find the GCF of 15 and 28. A student writes 5 because 15 has 5 as a factor.
But does 28 have 5? 28 is 2 squared times even. 15 is 3 times 5. They share no primes at all.
When two numbers share no prime factors, their GCF is 1. They are called co-prime. 1 is always a common factor.
So the answer is 1, not 5. The student only checked one number.
Trap 3. Simplify 24 divided by 4 times 2. A student writes 3.
They did 4 times 2 first and got 8. 24 divided by 8 is 3. But BODMAS says division and multiplication are equal priority. Left to right.
Left to right. 24 divided by 4 is 6. 6 times 2 is 12. The answer is 12, not 3.
Let me pause here for 8 seconds. What is the LCM of 9 and 12 using prime factorization?
Nine is 3 squared. 12 is 2 squared times 3. Highest powers. 2 squared is 4. 3 squared is 9. 4 times 9 is 36.
So LCM of 9 and 12 is 36, not 108.
Last trap. List all prime factors of 12. Students write 1, 2, 3.
But 1 is not prime. We learned that in part 1. Answer is just 2 and 3.
4 traps. Multiplying instead of LCM. Checking only one number for GCF. Wrong BODMAS order. And the 1 is not prime trick.
Divisibility shortcuts. 2 checks the last digit. 3 and 9 check the digit sum. 6 needs both the 2 test and the 3 test.
Prime factorization breaks any number into its prime building blocks using a factor tree.
GCF takes the lowest power of shared primes. LCM takes the highest power of all primes. They are mirror images.
And BODMAS is left to right when division and multiplication tie.
Now let me crack that lock. First 3 digits, divisible by 6. Middle 2 digits, GCF of 12 and 18, which is 0, 6. Last 3 digits, LCM of 4 and 6, which is 0, 1, 2. Wait, the middle 2 overlap with the first 3 and last 3. First 3 must end in 0, 6. Divisible by 6 means even last digit. 6 is even. Digit sum must be divisible by 3.
What 3-digit number ends in 06 and has digits adding to a multiple of 3?
306. 3 plus 0 plus 6 is 9. Divisible by 3. And it ends in 6, which is even. Both tests pass. 306.
So the 6-digit code is 30601.
30601.
Your chicken rice, slightly cold.
Worth it. Here's your challenge. Pick any 2 numbers between 10 and 50. Find their prime factorization using a factor tree. Then calculate both the GCF and the LCM.
Check your answer with the trick. GCF times LCM should equal the 2 numbers multiplied together.
Thanks for watching. Subscribe for more maths that actually make sense. See you next time.
I am already designing a 10-digit lock.